For problem 10, we are given that we have an normal process and wide stationary process, and we need to prove that it is a straight sense stationary process because xt is normal and while stationary process, so we have the expectation of xt equals a constant. Also, we have the autocorrelation of xt1 and xt2 is equals to the difference of xt1 and xt2. And because xt is normal and is normal, we have the density function and of fx and t. It equals to this formula. It is the property of normal distribution. And if we take a look at the correlation term, which is the c, equals to the expectation of x minus the expectation of x, which is mean of x, times the transpose of x minus the mean value of xt. And if we rewrite it in matrix formula, we have this form. We have this form. And because we have said that this is equals to a constant due to the property of wide stationary process. And similarly, we have xt1 to xtn. And times the transpose of this term. And extra. And if we try to combine these two together, we have actually this term times this term, and this we got the expectation of xt1 times xt1, and due to the property of wide process, it is equals to this constant value. And so we can rewrite the matrix C as this 0 is because t1 minus t1 equals to 0. And we have for xt1 to xtn, here should be xt1 minus xtn minus the mean values power of 2. And also we have here is xt1 minus xtn minus the power of mean value. And here is tn minus tn, so we got 0 again. And this is we rewrite the matrix C, and I will make the previous part smaller. And If we rewrite this form, we can get the correlation matrix is equals to T1 minus T2 and extra. So in general form, it can be written as Ti minus Tj, where I is not equals to j and I is from and ij is also from 0 to n. So after we have processed the correlation matrix C, we can get the density function of fxt equals to the density function of fx and ti minus tj for I is not equals to j. And we can rewrite and for if what we would like to prove that fx is a straight stationary process, we need to show this term, this equation equals to time shift by a range eta, where it should be a arbitrary value. And also notice that we can, based on the property we get from here, we can write this term as ti minus plus eta minus tj here, which is right t2 minus plus eta, and we have cancelled at each other, so we got this equation. Because we have cancelled eta, we got this equation is also equals to fx with x1 x2 to xn and t1 minus t2 minus t3 and etc, which is equals to equation of 1. So by these two, we can get that the xx is also a straight sense stationary process. For this problem, we think that we should have a clear sense of the property of wide sense stationary process. It satisfies the property of constant mean value and the correlation of x1 x2 equals to this one, and we also need to expand the correlation matrix C to get an view, to process into the view of xi minus xj.